In this video 3.1, we will be exploring square roots and irrational numbers. By the end of the video and work time in class, you should be able to say, I can find and estimate square roots. A perfect square is the square of a whole number. We're going to make a perfect square list here, starting with 0. 0 squared is 0. So 0 is a perfect square. 1 squared is 1. So 1's a perfect square. 2 squared, 4. So 4 is a perfect square. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36 is a perfect square. We'll keep going here. 7 squared, 8 squared, 9 squared, 10, 11, 12, 13 squared, 14 squared, 'and we'll stop there. So the numbers starting here was 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, and 289. Those are perfect squares. So the numbers that are underlined in red are perfect squares. You can take that many smaller squares. Let's say, look at 49 here. If I had 49 squares, I could make a square using 49 squares that would be 7 by 7. If I had 121 squares, I can make a perfect square that would be 11 by 11. So once again, the numbers that are underlined here in red are the perfect squares. They go on forever. We just stopped at 289. Square root now is kind of the opposite of what we were just doing. The square root of a number is another number that when multiplied by itself is equal to the given number. So like I was saying, it's the opposite of what we were just doing. So use your perfect square list to find square roots. We'll start with finding the square root. Here, I'm going to use a different color. Square root, we use our symbol, that's a radical symbol, of 25. So if you go back and you look at your perfect square list, and you find 25, you know that 5 squared is 25. So the square root of 25 is going to be plus or minus 5. And the reason why I'm saying plus or minus 5 is because 5 squared is 25. Or if I square negative 5 times negative 5 is also 25. So if I was looking at the square root of 16, what number squared is 16? Well, 4 squared is 16, but negative 4 times negative 4 is also 16. So plus or minus 4. If you see something like this, where you have a rational number underneath a radical sign, what you can do is you can split the numerator and denominator underneath two separate radicals. The square root of 1 is 1, and the square root of 16 is 4. And that would be plus or minus. If you had something like, let's say the square root of 70, you might be thinking, well, 70 is not on that perfect square list we wrote. So what we do is we look at where it falls. Is 70 closest to, let's see, 64, or is it closer to 81? And we know that 70 would be closer to 64. And the square root of 64 is 8. So I'm going to say the square root of 70 is about, use my about symbol, 8. An irrational number cannot be written as a over b. Some examples: pi. It's a decimal that goes on forever and doesn't repeat. The square root of 2. 2 is not a perfect square. If you put a number under the radical that is not a perfect square, that is an irrational number. If you typed in the square root of 2 on your calculator, you get a decimal that doesn't repeat and it will go on forever. So what we have with real numbers, we have rational numbers and we have irrational numbers. We've been working with rational numbers so far. We've been working with integers, which we know are whole numbers like 12 and their opposite, negative 12. We've been working with fractions like 3/4 or like a mixed number, 4 and 7/9. Terminating and repeating decimals. So a decimal that ends or a repeating decimal. Those are all rational numbers. Irrational is, like I said, pi, or the square root of an imperfect square, like the square root of 2, or the square root of 90, because 90 is also not a perfect square. They are decimals that go on forever, that don't repeat, and you cannot write them as a fraction, a over b. Can you say, I can find and estimate square roots? Here's your output to work out before class. Be prepared with any questions.